greeting to Dr. Aris. We are from Group 8. Today we want to present our group assignment. I will introduce my group mates. First me, Jayakumar Sivakumar. Second, Putri Julia. Third, Noor Shahira. Fourth, Siti Faradiba. And last one is Noor Asmiza. Literature review. First one is volume control. Volume control and potentiometers. The discussion how the potentiometers function as variable resistant audio circuits to adjust the sound loudness. Second thing is speaker mechanism. Explanations of speakers convert electrical signal into sound through the magnetic field interaction and cone vibration. The third thing is RMS vs peak voltage. Examinations of electrical concept, amazing difference between RMS voltage and peak voltage. And lastly is the Bakun Dam controversy in Malaysia, detailing analysis of environment, social and economic issues surrounding the Bakun Dam in Malaysia, embracing the massive of deforestation, degenerations and displacement and sustainable economic benefit. The first question is, how does a volume control potentiometer adjust the sound? A volume control potentiometer is a key component in audio system used to adjust the loudness of sound by controlling the strength of electrical signal sent to the speaker. When the knob is turned down, the most of signal is delivered to the ground, resulting in soft sound. Turning the knob up allows more the signal pass to the speaker. It is increase the loudness. This makes the potentiometers a simple rival and cause of effect the solution for smooth and precision adjustment.
Hi, my name is Naris Musafiti Mamarzi. Now I will present question number 2, which is explained with suitable diagram why RMS voltage is not same as the peak voltage. Root mean square voltage can be defined as the effective voltage of an AC waveform that provides the same heating effect as an equivalent DC voltage, and it measures the average power of the signal over time. Meanwhile, the peak voltage can be defined as the maximum voltage level reached by an AC waveform, either in the positive or negative direction, that represents the amplitude of the waveform, and it is the absolute maximum value that the voltage signal can achieve. The RMS voltage is calculated as Vrms equal to the peak voltage Vp divided by the square root of 2. For sinusoidal waves, Vrms is always less than Vp because it averages the entire waveform. The diagram highlights why are RMS voltage and the peak voltage not same to each other, as the RMS voltage shown at the lower level indicates the effective voltage value used for power calculations, while the peak voltage represents the maximum amplitude. The horizontal line represents Vrms level below wave crest, and the red line represents Vp as maximum waveform value. So that's all from my part. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Julia Jasnita. So, today I'll be presented about question number 3, which is with suitable description, explain the controversial issue of Bakun Dam in Sarawak. So, the Bakun Dam in Sarawak, Malaysia is a major hydroelectric project that has sparked significant controversy due to its environmental, social, economy and sustainability issues. So, first I'll be explaining about the purpose and construction. The Bakun Dam was built to produce over 2,400 megawatt of electricity, making it one of Southeast Asia's largest dams. Initially, it was planned to export electricity to Peninsular Malaysia via undersea cables, but this plan was later abandoned. So the project faced delays to financial crisis and protests, and it was only completed in 2011. Next, I'll be talk about the environmental concerns. So the dam flooded over 700 square kilometers of rainforest, destroying biodiversity and natural habitats. Additionally, the decomposing vegetation in the flooded area released methane, a greenhouse gas that contributes to climate change. So next is on social impact. Over 10,000 indigenous Orang Ulu people, including the Kenya and Kayan tribes, were displaced from their home. So they were located to the Sungai Asap, where they faced the loss of traditional lands and livelihoods. Many struggled to adapt to the new environment, making the resettlement extremely challenging. Then we have an economic issue, which is the project cost over 15 billion ringgit Malaysia, which raised concern about financial viability. So furthermore, Sarawak energy demand remains below the dam capacity, leaving much of its potential underutilized and questioning the project economic returns. And last but not least is the sustainability issues, which is the environmental destruction and social cost of the dam. Challenge is sustainability. While hydroelectric power is renewable, projects like this highlight the importance of balancing development with ecological and social considerations. So in conclusion, the Bakun Dam reflects both the benefits and also challenges of large-scale development. So it reminds us that progress must respect both people and the planet. So that's all from me. Thank you.
So Assalamualaikum, my name is Najarihan binti Miskam. So I will explain about question 4, which is determine the half cycle average value of the voltage across R1 and R2, and also I will explain how we use the multism software. So first, we understand that the SC waveform is essential in electrical engineering as it helps in real-world applications such as power electronics and signal processing. So our goal is to determine the half cycle average of voltage across R1 and R2 using the given RMS value. So we will calculate the peak value and the average value using a fundamental electrical equation and validate our finding with multism software. So to verification of multism is to confirm our theoretical calculation. We use a multism simulation which is includes a circuit schematic, the display the circuit components and connection. Next is multism readings, to confirm RMS value, peak value and average voltage value. And next is oscilloscope waveform, to show how the voltage behaves in real time. So next is our simulation result match our theoretical calculation, confirming the accuracy of our approach. The waveform oscillation align with expectation, verifying that our equation correctly predict a voltage behavior. So in conclusion, we just determine the half cycle average value using RMS value. Next, to convert the RMS voltage RMS to peak to voltage peak and values, and apply the half cycle average formula. Last, validated our result with multism software and proving the practical application. So this analysis is vital in electrical engineering, particularly in AC circuit design, power system and signal processing. So that's all from me. Thank you.
Assalamualaikum to Dr. Haris. My name is Siti Fariba binti Muhammad Sofi. I will present about an analysis of a sine wave that is riding on a DC offset. We will explore is theoretical calculation and validate the results using multisym software. This topic is important in signal processing and circuit design, where AC signals often interact with DC components. We have a sine wave with an RMS value of 10.6 volts, which is combined with a DC offset that 24 volt Our objective is to determine the maximum and minimum values of the resulting waveform and verify our calculation using a multi-sim simulation. To verify our theoretical calculation, we use multi-sim software, a circuit simulation tool that allows us to visualize and analyze waveforms in real time. As shown in the image, the multi-sim simulation consists of two key components that are schematic view, display the circuit setup, including the sine wave source and the DC offset. Next, graphical analysis shows the waveform oscillating between 9.01 volt and 38.99 volt, confirming our theoretical result. In summary, this problem illustrates the interaction between AC and DC signals. The RMS value of a sine wave helps us determine its peak voltage using the factor 1.414. Adding the DC offset shift the waveform up or down. Multisim is a powerful tool for validating theoretical calculation in circuit analysis. That's all from me. Thank you.